All right, we are going to make some scatter plots in this lesson as well as talk about line of best fit and start using our graphing calculator. In number one, they ask you to draw a scatter plot of the data and tell whether it shows positive correlation, negative correlation, or approximately no correlation. So the first thing you have to do is plot the various points. They have stacked the two tables on top of each other. So I drew a red line in there just to show you that instead of making a table completely horizontally across, they've just broken up the table into two sections um, and stacked them on top of each other. It's just to save space. So the first point is right here. So that's point number one. Then you go down point number two, point number three, so on and so forth. When you get to the end here, so here's a point and here's a point, then you just go down here. That's your sixth point, and then you just continue across in that manner. So take a minute to pause the video and go ahead and plot your points. I went ahead and did it for you just so you could see it, but go ahead and plot your points and then you can start the video back up. So the second thing they ask you to do here after you have plotted all of that is to describe what the correlation is like. So positive correlation is the same idea as positive slope. If reading the graph again from left to right, just like we do with slope, if the points are in general going up in an upward direction, then you would say it has positive slope. So in this case, this particular problem has positive slope, positive correlation. If you do a problem and the points in general take a negative trend, so left to right, they go down, then you would say that was negative correlation. Same idea as negative slope. And no correlation just means they're sort of all over the place. There's not really any specific direction that they're going altogether. They're kind of just all over the graph with no correlation seen at all. Now down here on number three, they went ahead and graphed the points and also drew in the best fitting line for the data. So a line of best fit is the line that goes through most of the points, or at least goes through kind of the space in which most of the points are. So on this particular one, you can see there aren't actually a whole lot of points that are specifically on that line, but they're all very generally close to that line. So I took the 2 points and circled the 2 points that are actually on the line, and I found the estimated, just kind of eyeballing it, the X and Y coordinate points for each of those. And so then, in order to figure out the actual equation for that best fitting line, then I'm going to calculate the slope using those 2 points. So we'll do our change in y's over our change in x. And that slope will end up being a negative 2/3. So now I can go back and actually look at that graph and see where it crosses the y-axis. And it's up there at that point 2.25. So I know my y-intercept then is at 2.25. So I didn't have to do any calculating for that because I actually have the graph to look at. And then we go ahead and fill in our m and our b. And there we just made an equation for the best fitting line for that data. Now on 5, they gave you the table of points again, just like they did in that first problem on the worksheet. And they want you to draw the scatter plot, and then they want you to approximate the best fitting line for the data. So you need to pause the video, take a moment to plot those different points, and then flip the video back on and we'll draw that best fitting line. All right, so you can see that I've taken the ruler and kind of laid it in those points so that the ruler is going through and most of those points. There are going to be some outliers, but we want it to be the line that kind of goes and hits or is in between most of the points that are there. And then you just draw your line. Okay, and then I chose the point here, and one of the points down here, I think my green line kind of covered it, and to calculate slope with. Um, so those points used to calculate the slope, change in y over the change in x. And I'll end up with 1.2 for my slope. Again, because I have a graph, I can go back to that graph and look and see if I can estimate that y-intercept, and I can on this one. It's going right through -3. Right here at -3, so I can say that's my b, and then write out my equation, plugging in 1.2 for my slope and -3 for the y-intercept. Now, for the word problem, they've given us a table that shows the number of adult softball teams for the years 1999 to 2003, and they've given that to us in table form. Our year is our X, and the number of teams in thousands are our Ys. If you look down at the table, it's years since 1999. So that's the 1999 is actually lines up with 0, then 2000 is then coordinate point 1, and so on and so forth, since it's years since 1999. So you just go in and plot those points. And then they ask us to actually use a graphing calculator to approximate the best fitting line for the data. So this is when we're going to learn how to put these data points into the calculator and have it help us find our slope and our y-intercept. All right, so you'll want to turn on your calculator, which should be at the bottom left of the calculator, and then you're going to hit the stat button that's at the top next to the arrow keys. And it's going to pull up this screen that looks like this. You want to click on edit, and then it's going to bring you to a screen that looks like this. If anyone has used this calculator before you, then you are going to probably have some values in here for L1 and L2 that are not the values that we need. And so you'll have to clear those out. You can come down here to this delete button. You just use your cursors, okay, your arrow keys over here. These blue keys will take you up and down the line, and you can just delete out what you don't need. If you don't need any, if there's nothing there, then you're good. But if there are things there, then just put your cursor over it and hit the delete, and it'll take that number out. And then you just want to delete everything out. The L1 is going to be your X values. So you can see that I already plugged in the X values 0, 1, 2, 3, and 4 that are going along with this problem. And then L2 is going to be your Y values. So that's the 163 all the way down to 119. That's from that table there. So once you've entered those points, your X, Y coordinates for each of those, you're going to go back to the stat key and click it. And now you see where we started from, but you want to click your arrow over, your right arrow over until you get to calc. And it'll pull up this menu. And then depending on what version you have, if you have an 83 or if you have, it depends on whether you've got an 82, 83, 84 as to this menu. It might look a little bit different, but you want to scroll down until you get to the number that says linear regression. LINREG. Okay, and you can see it's got the y equals mx plus b form right next to it. They're calling slope a instead of m, but this is your slope form, your y equals mx plus b form. And so you want to hover on that and then hit enter. And what comes up is the slope, your a. Again, they're calling it a instead of m here. So your a for this line is -10, which makes sense if you look at the way you plotted the data points for number 8. You do have a negative correlation, so you would expect a negative slope. And then your y-intercept is 165.8. And if you look at where we plotted, that's about right. Okay, that's about right where the line of best fit would go through. So you take those points then, and you use them to answer number 9. So approximate the best fitting line for the data. That would be y equals -10x plus 165.8. All right, and then number 10 asks you to use the model to predict the number of adult softball teams in 2010. So that's not on our chart. It only goes up to 2003. Our graph only goes out to year 5 after 1999. Okay, so to year 2004. And we want to go to 2010, so that's going to be an x of 11. All right, 2010 is 11 years from 1999. And so with an x of 11, we're going to use that to evaluate our function. And when we do that math, we'll end up with 55.8. If you go back and you look then at how that fits into the data up at the top, you can see that it has been declining. So we do have negative correlation. There are less softball teams as the years go on from 1999. And so what we got when we evaluated makes sense with what we're seeing with the data, which gives you a good indication that you were on the right track and have the right answer.